also do some calculus problems to help myself wind down and get ready for bed. And I think that doing calculus problems would be very relaxing for an ASMR video. That's what I'm gonna do for this video. I just bought some new legal pads from Walmart. I bought a pack of 3 of them. So that's what I'm going to be writing on. And I have my laptop here, so I'm going to search for some problems to do. I think I will just search for an AP Calc practice exam, or like some kind of previous exam questions, because those are usually fun to do. Let's see. AP Calc BC. So I can get the past exam free response questions. So that's what I'm gonna do. Let's go to 2024. Okay, I'm looking for the section that doesn't require a graphing calculator, because I don't have one on me right now, and I could just use Desmos, but I just want to do everything on paper. I don't want to use my laptop except to look at the problems. So we'll go to the no calculator section. Plus the no calculator ones are always more fun anyways. The calculator ones are boring because, I mean, you just put everything in the calculator and it does it for you. But the no calculator ones are more satisfying to work out. So you might be able to hear the birds outside my window because, like I said, it's 4 o'clock in the morning and the birds have already started chirping and waking up. So I'm not sure if the mic on my iPad will pick them up, but they might. But I enjoy falling asleep to the sound of birds, like waking up in the morning. Oh, okay, here's a good one. Let's do this one. This one says, the graph of the differentiable function f shown for -6 is less than or equal to x, which is less than or equal to 7, has a horizontal tangent at x equals -2, and is linear for 0 is less than or equal to x, is less than or equal to 7. Let R be the region in the second quadrant 6 and the x and y axes. Region R has area 12. And then it has a picture of the graph. So I'm going to recreate the graph on my paper. How should I do this? I'm not sure if people will be interested in seeing like what I'm writing down. I mean, if I was watching this, I would be interested to see. But my original idea for this video was just to do the problems off camera and just talk through them as I'm doing them, and have the ASMR be kind of like the writing sounds and the whispering of the math. So I'll do that. I'll do that for now. And maybe in another video I can do one where I'm showing my screen, or not my screen, my paper, and kind of work through the problems that way. So, okay. So I'm gonna recreate the graph that it gives us, and maybe I'll show you just for fun after I draw it. So it's a curved function from -6 to 0, and a linear function from 0 up until x equals 7. And so its region R is bound by the line, the vertical line x equals -6, the x-axis, the y-axis, and the differentiable function f. So again, I'm just copying down the graph that the problem gives me, because I like to redraw them myself anyways. So the function f has points labeled at 6, 6, -1, and -6, 0.5, and the region R has an area of 12. It says there is a horizontal tangent at x equals -2. So I'm going to draw a horizontal tangent at x equals -2 as well. And we also have the point 0, 2 for the y-intercept. Okay, so I redrew. I may have to flip my camera so that the drawing is visible. So here's our function. It's supposed to be straight for this region, and then it curves for this region. And this is region R, which has an area of 12. Did I write that wrong? I didn't. I just can't read my own handwriting backwards. Apparently that thing is a 2, which I did not recognize. And we've got points at 0, 2, -6, 0.5, and 6, -1. So, part A of this problem is asking us to find the values of g of -6, g of 4, and g of 6, where g of x is defined as the integral from 0 to x of f of t with respect to t. Okay, so this is a pretty straightforward problem. We don't even really need to do any intense calculations here. So let's see. Maybe we'll start with g of -6. G of -6 would be the integral from 0 to -6 of f of t, which is the same thing as the negative of the integral from -6 to 0 of f of t dt. And that's really easy because if we look at our function right here, we can see that f of t, or in this case, oh, I like that sound. I don't know if it'll sound as good on camera, but yeah, anyway, this is a pretty straightforward one because the integral from -6 to 0 of f would just be the area under the curve from -6 to 0 of f, which were given in the problem as region R, which has an area of 12. So the answer here is just -12. G of 4 would be the integral from 0 to 4 of f, which again we can just read directly off of our graph. So from 0 to 4, f goes down here like that. So we just need the area that's like right under here, this little triangle. And the area of the triangle is just the base, which is 4, times the height, which we're also given is just 2, and then divided by 2. So that just becomes 4. So g of 4 is just 4. G of 6 is the same idea. We want the area under the graph from 0 to 6. And we already know that the area from 0 to 4 is going to be 4. So we need the remaining area between the x-axis and the graph, which will just be this little part here, this little triangle from 4 to 6. So if we find the area of this triangle, then we know that the integral will just be the negative of whatever this area is. So we can do that because we're given this point here as being 6, -1. So that means we know we have a triangle with a base of 2 and a height of 1. And then that will be all divided by 2. Base times height divided by 2. Base times height divided by 2. So that would just be our base of 2 times our height of 1 divided by 2, which is just 1. So that tells us that the total integral of f from 0 to 6 is going to be 4 plus negative 1, which equals 3. Okay, that one was kind of boring. Okay, the next part to this problem is, what does it say? Okay, it says for the function g defined in part A, find all values of x in the interval 0 to 6. So I'm gonna write this down. I'm not sure if you can hear my writing. I'm hoping that the camera picks it up because I think writing sounds are nice. But again, I'm filming on my iPad, so I don't know how well the audio will get picked up. So I'll just have to see. But anyway, part B of this problem says for the function g, defined in part A, find all values of x in the interval 0 to 6 at which the graph of g has a critical point. A critical point. And it says give a reason for your answer. Okay, before I start this next part to the problem, I'm gonna light my candle. I'm like scared now because I accidentally started a fire in my house like just recently. Like a small one. But it does make me a little worried now. Okay. I'm gonna put that down. Alright, now, where were we? So we want to figure out all the values within the region x equals 0 to x equals 6, at which the graph of g has a critical point. And critical points are defined as places where the derivative of the function is 0. So we want to figure out where is g prime of x, which equals the derivative of g, equals 0, or undefined. An undefined derivative at a certain point is also a critical point. So we need to figure out where is the derivative of g equal to 0. Well, we know that g is defined as the integral of f from 0 to x, which tells us that the derivative of g with respect to x is just going to equal f of x. And we already have the graph of f of x given to us in the problem. So g of x is defined as the integral from 0 to x of f, which means the derivative of g is just going to equal f. And if we want to figure out where does the derivative of g equal 0, then that means we want to know where is f equal to 0. And if we look at our graph, we can see that from 0 to 6, f is equal to 0 at the point x equals 4. So moving on, I mean that's basically it for that point. We don't really need to do much else because we know that f equals 0 for x equals 4. Our critical point occurs at x equals 4. Alright, let's move on. Okay, so part C. The function h is defined by the integral from -6 to x of f prime of t with respect to t. And it says find the values of h of 6, h prime of 6, and h double prime of 6. Show the work that leads to your answers. This one's also kind of boring, but I mean, it's a little bit more interesting than the previous two problems. Because now we have our new function h, which is now defined as the integral of the derivative of f. So apparently one of my neighbors is completely insane, and client is mowing their lawn at 4 o'clock in the morning. Well, it's 4:40 now, but still, like, why? Why? I really hope the camera does not pick it up, but it might. Who mows their lawn at 4 o'clock in the morning? Maybe they have no other time, or they can mow it, but like, that feels psychotic to me. Okay, I just listened back to some of the video recordings, and I don't think that the lawnmower is being detected by my audio, so hopefully that stays that way and I can keep recording my math problems. So we were in the middle of part C to this problem, where we were given this function h of x defined as the integral from -6 to x of the derivative of f. And we want to find the values of h of 6, h prime of 6, and h double prime of 6. So, if we want to find h of 6, then that's just going to be the integral from -6 to 6 of f prime of t with respect to t. And for this one, we can use the fundamental theorem of calculus, because we're just integrating f prime of t, and the fundamental theorem of calculus tells us that the integral will be equal to the antiderivative of the integrand evaluated at the two integration bounds. And since our integrand is f prime of t, that means our antiderivative is just going to be f of t. So the integral from -6 to 6 of f prime will be f of 6 minus f of -6. And again, we can read these off of our graph. So, f of x is equal to -1, and f of -6 is equal to 0.5. So this is just equal to -1 minus 0.5, which equals -1.5. Now we can find f prime of 6. So f prime of x, that's just the derivative of h of x. And since the derivative, since h is defined as the integral of f prime, then the derivative of h of x is just going to equal, basically it's going to cancel out the integral. So the derivative of h of x is just going to be f prime of x. F prime of x. So then the value of the derivative of h at x equals 6 is the same thing as the derivative of f at x equals 6. Now my house house is also being loud. It's just it's not a good time to record apparently. I thought that doing it in the middle of the night would give me some quiet, but I guess not. Again, I might get lucky and the sounds might be quiet enough that my iPad mic doesn't pick them up. So I'm hoping that's the case, but if not, I'll just keep filming and then I can just cut out all of the loud sounds that my house makes, or at least some of them. Like right now, it's making a lot of complaints, but I don't know if you can hear them on video, so let's just continue for now. Like I was saying, the derivative of h evaluated at 6 is just going to be the derivative of f evaluated at 6. And we can go back to our graph of f and just read off the derivative at x equals 6, because the derivative is just going to be the slope of the tangent line. And there's kind of two ways that we can do this, in my opinion. We can either just notice that this is a linear function, just a straight line, so the slope is going to be the same for every value of x from 0 up until 7, or 6, or wherever it stops at. So we can find this slope, and then that will be the derivative. And another way you could do this, which is actually the same way but with extra steps, is to find the actual equation of this line. So it'll be something of the form y equals mx plus b. And we have the y-intercept, and we can also find the slope. And then if you wanted to, you could take the derivative of that equation, and of course the derivative would just be m, like the slope. So it's the same thing that we did before, but with a more, I don't know what the right word is, just like putting it into an equation and then finding the derivative from there. So, but it's the same thing mathematically. Okay, so looking at the line for f, we can see that it's going to go down. It's going to go down by 2 in the y. So the vertical component will go down by 2 units, and the horizontal component will increase by 4 units. So that gives us a slope of negative 1 over 2. So that means that the slope of the tangent line at x equals 6 is just negative 1/2. So our answer is negative 1/2. And the next one wanted us to find the second derivative of h evaluated at 6. So it's the same idea. The second derivative of h is just going to be the second derivative of f evaluated at 6, or evaluated at x equals 6. And since we know that the derivative of f is just going to be constant, then the second derivative is just going to be 0. So h, the second derivative of was not very interesting to do, and doing it ASMR style takes so much more time. But I still think this is a cool video idea. I just want to figure out the best way to do it. So it's getting late now. I'm gonna do probably one more problem, and then I'm gonna do probably one more problem, and then I'm gonna go to bed. So let's. Alright, so this one is a differential equations problem. Those ones are also usually pretty straightforward, but they're not that interesting because they're all just separation of variables. So let's see. Yeah, actually, I'm just gonna end the video here then. But I do enjoy this